example 8. Now when she's running, we'll see that the velocity here is a positive number, but here the velocity is negative. But speed, which is a scalar quantity, is 3 meters per second here and also 3 meters per second here. For the first part, we want the distance that she runs in total, not the displacement but the distance. So we want the area of 3 separate regions on the graph. These 3 rectangular regions, and if we calculate the area for each, we see that she travels 270 meters. The distance of the woman from A when t equals 50 is actually asking for the displacement. So anything above the horizontal axis is positive, anything below will be negative, and if you add them together, 90 plus minus 60 gives us 30 meters. So when t equals 50, there, t equals 50, the displacement, or the distance from A, is 30 meters. So when t is equal to 80 seconds, again calculating a displacement, anything above the horizontal axis is positive, anything below is negative. So this would essentially be 90 meters, that's 60 meters. This one you have to calculate as minus 90 meters, and if you add them all together, these will cancel, it leaves you with 60 meters. So the distance from A is 60 meters. Now on the graph, when the woman starts from A and runs towards B, at B she turns around and runs back towards A with the same speed, so the velocity is the same but in the opposite direction. Okay, I should say the speed is the same but in the opposite direction. So there's a reverse of direction here, and now she's running from B towards A. She reaches A, reverses direction again, and is now running in the opposite direction. And the distance from A to B is 90 meters. So initially a child starts to walk from A towards B at a constant speed for the first 50 seconds, and then at an increasing speed for the next 40 seconds. The speed is increasing. The question doesn't mention whether the acceleration is constant. I'm assuming a constant acceleration here, which is why the gradient of this line is the same. If the acceleration wasn't constant, then you could have had a curve or something like this on the graph, and then you'd need calculus to solve problems with. But we'll assume the acceleration there is constant, and you need acceleration for the velocity to increase. So if the woman and child pass each other, it means their displacement measured from A is the same. We know that the displacement of the woman is 30 meters from A. During the first 50 seconds, the initial and final velocities for the child are the same. So the displacement of the child is just the child's initial speed multiplied by time taken. So 30 meters traveled, u is what we're looking for, multiplied by 50. So u is equal to 3/5 or 0.6 meters per second. After 50 seconds, we know that the child's speed is increasing, so there's acceleration. At t equals 80, the woman has covered 60 meters, so that 60 meters is the displacement measured from A, not the total distance travelled. And we can see from our graph, when t equals 80, she is moving from A towards B. So because the question says that the woman overtakes the child, it means that they are both moving in the same direction, not like before when they were moving in opposite directions. So when the woman has a displacement of 60 meters, the child also has a displacement of 60 meters from A, and if we look at how far the child has traveled in the first 50 seconds, where the child was going at constant velocity, it's 30 meters, so the child has another 30 meters still to travel to get to this point at 60 meters. We've been told that for the first 50 seconds there was constant velocity, so we need to treat that part of the motion separately from the part where the child is going increasingly faster, so where the child is accelerating. So in the first 50 seconds 30 meters is covered by the child, and then we now need to look at the remaining 30 meters the child has to still cover to get to 60 meters, but separately. So if we look at Suvat, so we have 30 meters to cover. The initial speed is 0.6 meters per second. This is what we're after. I've crossed out the acceleration, we don't need to know what it is, but this is interesting. T is not 80, T is 30. Okay, so in total the child has taken 80 seconds to get from A to this point. However, in the first 50 seconds the child covers 30 meters, but to get to 60 meters a further 30 meters remains. Okay, so if we look at the motion during which the child is accelerating, the child still has 30 meters to cover. That was the initial speed. V is what we're after. A we're not interested in, so I've crossed it out. And T is 30. The accelerating part of the child's journey is of duration 30 seconds to get up to here. So you've got 80 seconds in total, 50 seconds for constant velocity, leaving another 30 seconds for acceleration. Suvat formula, substitute the values in, we get V equals 1.4 meters per second. The main thing in this problem, it's a multi-stage problem. You look at the child's motion where the velocity was constant separately from the child's motion where there was acceleration.